Okay, everybody, let's get back to this matching rock layers lab. Again, this has to do with relative dating, which we talked about in some of the other videos. And we did procedure A in the last video, so I want to focus on procedure B at this point. And for procedure B, it says to reconstruct the complete sequence of events and draw the layers with the fossils, if present, on the appropriate column of your report sheet. Now again, I'm trying to walk you through these labs because they aren't the easiest labs to do, and I think you'll probably get pretty stuck if you were on your own completely. And then it says, by referring to your reference tables, identify any layer for which you have enough evidence to determine its age. And we'll get to that in a minute. So let's go take a look at the second set of diagrams. So if you remember last time we recreated this complete column of rock in procedure A, and we used A, B, C, and D. If you didn't do that, look at the other video. Now we're on to this part down here. And just like before, essentially we have to match up these four rock layers, or four rock sequences. This is a little bit easier than what we did in procedure A. So basically what we're going to do is take the columns for A, B, C, and D and combine them together to make one complete column and draw that here under procedure B. And again, I'll walk you through that. This is a little bit easier than what we did before, I think, because on this one, there's no unconformities. And remember, an unconformity represents missing rock, where we had weathering and erosion taking place. And when we did these from procedure A, there were just areas where there was missing rock units, like here and up there. This one doesn't have any unconformities, which makes it just a lot easier to work with. So what we need to do is basically match things up. If we were in the classroom, what I might have you do is actually take scissors and cut these out and put them side by side and try to line them up horizontally. But we're obviously not there. So if we take a look at this, what we need to do is try to find where there are matches in the rock layers, where the rock layers seem to kind of match up. And if we look at column A, we have some siltstone, limestone, we have shale with a trilobite, we have some sort of igneous rock. If we're using the same legend, I'm not sure we are, but that was basalt, so probably basalt. Contact metamorphism here, contact metamorphism here. We have sandstone, this is a fossil crinoid. There's a legend over here. We talked about all these fossils in other videos. Anyway, we need to try to find matches. So here I've got the crinoid, and then if I look, here I've got more of that basalt, contact metamorphism, and a sandstone layer. So what I could assume is that the bottom of rock layer C probably matches over here, and that this sandstone is probably the same sandstone that this crinoid is in, and that if we were to cut out C and move it, we would have it lined up here pretty nicely. And now we have this snail shell, or gastropod shell in some shale. These two seem to match up fairly well. So now we have a match here. And that means that this limestone and this shell would be higher up in the column. These two shells match here. And this means that we would probably have the conglomerate on top, which means that in this example, this conglomerate or whatever that might be would be our youngest rock layer. So if we go to procedure B here, well, the first thing we're going to do is draw column A. This is our oldest sequence of rock. So I'm going to have column A drawn. It's just to draw the fossils. We could do the best we can with that. So I'm going to start out by having my siltstone, which would be like this. Then we have the layer of limestone next. If we are reproducing column A, essentially, that's what we're doing. So now we're going to have limestone. I'm going to do something like this. Then the next one is the shale. And it has this trilobite in there, and I'm going to try to sketch a trilobite. It doesn't have to look that perfect, but we could do something kind of like this, something like that. That's good enough. So we've got our trilobite. We had some contact metamorphism here. If this is a shale, and then above the shale we have basalt cooling and hardening, the heat from that magma when the basalt was molten is going to alter the shale and make the metamorphic rock slate, right? That was an idea that we talked about in the past. Then we have our sandstone. And again, the heat from the basalt converts some of that sandstone into quartzite. We have the crinoid. So I'll try to draw, put that side by side actually. Let's try it like this. Now we have our crinoid. Again, I'm just drawing column A basically. And I'll draw something like that. Again, crinoids lived on the seafloor. They had tentacles. They would wait for tasty things to come along and catch them in their tentacles. So that's column A. Now here we have the basalt, the sandstone. So now above that would be the shale with this snail shell, or it could be an ammonite. Oh, it says ammonite right there. Okay. Different creature. So now I'm going to have shale, and I'll try to draw something that looks kind of like an ammonite. So there's our ammonite there. And now we work up the sequence. So now we're at the ammonite, which means if we keep following up B, now we have limestone being the next rock layer. So there's the limestone. And then above the limestone, we have another layer of sandstone with this pecten, basically a mollusk or a clamshell. So I'm going to put in sandstone. We'll just draw something that looks, kind of shell-like. It doesn't have to be that perfect. There's my little clam, like that. And if we look at the diagrams, well, here we have the clamshell, and on top of that clamshell is some conglomerate. So now I'm going to have conglomerate being the last rock unit up here. Okay. And now we have our complete sequence for procedure B, which looks like that. And we have the fossils sketched in. So I've got my siltstone, my limestone, my shale with the trilobite, the basalt, sandstone, shale, limestone, sandstone, conglomerate. Okay, then if we go back to the procedure, the next part of procedure B said to refer to the reference tables, identify any layer for which you have enough evidence to determine its age. That's something that we haven't talked about yet, and we'll go over how to do that now. And then it says on the report sheet, label its age and period/epoch, and we'll talk about geologic time in another video, but we can go over it quickly now. The abbreviation MYBP stands for millions of years before present and may be expressed as a range of several million years. So now we're going to take out the reference table. If you don't have your reference table, you can certainly print one out. If you just type in New York State Earth Science Reference Table, it's the first thing that comes up. Now, in the reference table, we're going to go to page 8 and 9. And page 8 and 9 are kind of hard to look at. They're big. There's a tremendous amount of information in there. But for today, we're basically looking at page 8, mostly anyway. And here we have the geologic time periods. And this is something we'll do a whole lesson on. I'm sure almost all of you have heard of the Jurassic period, and that would be right here. We also have the Cretaceous and the Triassic. Dinosaurs lived during that time as well. Up here we have Paleogene, Neogene, Quaternary time. This is more recent time, most recent ice ages and such. This is the age of mammals. Dinosaurs are now extinct. If we go below the Triassic, now we have ancient, really old time from the Cambrian going up to the Permian. This is before the age of dinosaurs. This would be like ancient fish and some of the earliest creatures that roamed the earth. And again, we'll do a whole series of lessons on this chart and geologic time. I don't want to get that much into it. I want to just get you enough so that you can successfully do the lab. So to identify the times, basically what we're going to do is look at the fossils. And here we have a trilobite. And if we look at the trilobite in the lab, it looks to me very much like trilobite C down here on the bottom of the reference table, Phacops. And then what you would do is to figure out the age, lay the two sides or pages side by side, and we can see these bars with letters. So this particular trilobite has a letter C, and if we find letter C here, letter C is over here, if I follow that across, it matches with Devonian, which would go from 416 to 359 million years ago. So for this part here, we know we're dealing with Devonian time, and that was, according to the reference table, between 416 and 359. You'll see MYA a lot, millions of years ago. Because these two layers are under the Devonian fossil, we know that they're older. We don't know how much, but we know that they have to be older, right? Now we're going to do the same thing going along. We're going to find our crinoid. These are the Latin species names, but this would be our crinoid, letter H. So I'm going to find H. H is over here. And that doesn't quite match up because that's Silurian. Oh wait, maybe it's I. Interesting. So the crinoids go from all the way to Ordovician to present day. And this crinoid should be Mississippian, but I don't see it on the reference table listed that way. Interesting. Maybe it's a different species. I'm not sure. Let's put down Mississippian though for the crinoid. And Mississippian. Which would be from 262 to 323 million years ago. Okay, then we're going to go to the crinoid, or the ammonite rather. The ammonite, this particular one, is from the Cretaceous period. Which would be 142 to 65 million years ago. And then we have this clamshell, which is from what's called the Oligocene, which would be 33.7 million years ago to recent time. It's still in existence today, which means the conglomerate is the youngest. This rock layer is between these age ranges, and this basalt has to be between Mississippian, Devonian time, and so on. So anyway, that's a basic overview of how to do Procedure B. We'll do a whole series of lessons on geologic time next week. All right, so that's all for now, and then I'll post a separate video on Procedure C.